Hello everyone and welcome to TLE Eliminators PCD for Leetcode Weekly Contest 469. Sorry for the delay guys. Just having some technical issues. How was the contest? How was the contest guys? How many questions did you guys get? A third. Okay, so I guess you got till second. I see. Okay, so we'll get into the problem soon. We'll be discussing A to C because I could solve only up to C in this contest. Okay, so let's get right into it. Before starting, as usual, I'd like to inform you that um, our self-paced courses are live right now on the TLE Eliminators website. So if you go to tleeliminators.com/courses, you get to see our self-paced courses, which are for four different levels of competitive programming, all the way from the extreme beginner level, all the way to expert on code forces. So if you can solve three problems, this teaches the level four teaches you how to solve the fourth problem on code forces. And each level has specific topics. So if you're weak in a particular topic, let's say you're weak in binary search, then you know that you need to study level three, right? And each level has more than 40 hours of recorded lectures, more than 100 plus curated practice problems, hints and video solutions for all the problems, as well as DAO support available almost 24/7, right? So go check out the course. Second wala sirf some test cases, okay. And third one was backtracking based. No, third one was normal DP in my opinion. But yeah, let's get into the questions one by one. Okay. So the first question I think was pretty simple, so we won't spend that much time on it. Compute decimal representation. You're given a positive integer n, and a positive integer is a base 10 component if it is the product of a single digit from 1 to 9 and a non-negative power of 10. So for example, 537, these are base 10 components, while 537, 102 are not, etc. We have to express n as the sum of only base 10 components using the fewest base 10 components possible. Return an array containing these base 10 components in descending order, right? So how do we, so how do we do this? So let's just write down. So I'm having some issues with my pen tab today, so I'll be using my mouse. So please don't mind that. Okay, so let's get to problem A, right? Okay, so what we know is that every number like 537, we need to express it as sum of base 10 components, right? And we need to do using the fewest base 10 components. So obviously the easiest way to do it is by doing its decimal expansion, right? So we need to write its decimal expansion. Like for example, 537 equals 500 plus 30 plus 7, right? So this is how we express a number in decimal format. That's how decimal number system works. So basically all we need to do is just like find remainders with 10, right? And divide by 10 each time. And then we need to form this representation. So for example, we need to put this in an array in descending order. So our answer will simply be like 500, 30, 7, right? So, so for this, all we need to do is simply, we can do like while n is greater than 0, right? While n is greater than 0, we can start from the last digit, right? We can start from the last digit. And what we can say is basically we'll take our current value will be n mod 10, right? N mod 10 multiplied by whatever your current power of 10 is, right? By your current power of 10. And we can push back this value we can push back this value into our array, right? Push back. So this is how we find all the digits of a number, right? So one by one, we're finding all the digits and we're pushing them back with the appropriate power of 10. And then we can divide n with 10, right? So roughly this is the pseudocode for it, right? Obviously, if n mod 10 is equal to 0, if n mod 10 is equal to 0, then we don't need to push back anything. We don't need to push back 0, obviously. So we just need to keep that in mind. We can just check if n mod 10 is equal to 0, then we don't need to do this line. Okay, if it's 0, then don't need this. Then we don't need to push back. Don't push back. Okay, so that's all. Let's have a quick look at the code. So yeah, so we define our vector answer. This is our power of 10. So initially it will be 1. I just called it null over here, right? If we check if the remainder is positive, right? If the remainder is positive, we'll push back this null times the remainder. We'll divide n by 10, and then we'll increase our null by 10 because we want null to represent the current power of 10, right? Now in the end, we'll get something like the smallest one followed by the larger ones. So we will reverse the whole array and then we'll return the answer, right? So is everyone clear on this? Everyone clear with this question, right? And the time complexity of this will be simply number of digits. So time complexity will be big O of number of digits, big O of digits, right? And that is simply equal to big O of log base 10n, right? Is everyone clear with the first question? We'll move on to the second question. Okay, let's move on to the second problem now. Okay. The question says split array with minimum difference. So we are given an integer array of numbers. We need to split it into exactly two subarrays, left and right, such that left is strictly increasing and right is strictly decreasing. We need to return the minimum possible difference between the sums of left and right. If no such valid split exists, we can return -1. So they're just defining subarray and they're defining what strictly increasing, decreasing means, right? And they've given a few examples. So let's take this example 1, 2, 4, 3. Okay, right. So basically, the question is saying, let's say we're given an array like this 1, 2, 4, 3. Okay, so what we need to do is we need to choose a strictly increasing portion. Like, for example, as you can see, this portion is strictly increasing, and then we need to choose a strictly decreasing portion. Okay, so in this case, since we've already chosen 1 to 4, then only the remaining element is 3. So that is our strictly decreasing portion, right? Another way we can choose this is to choose 1, 2, and then choose 4, 3. Okay, so these are our two options. Note that we cannot choose 1 and then 2, 4, 3. We cannot choose 1 and 2, 4, 3 because then this one, it is not strictly decreasing, right? We want this to be strictly decreasing. Okay, so one of our options is 1, 2 because this is strictly increasing, and the other option will be like the other half will be strictly decreasing. Okay, so now this is a valid split, right? This is a valid split. So around this point, it's a valid split. So now we can take the sums of both of these and we can compare. Okay, so we can take sum of this is 3 and sum of this portion is 7, right? And 3 minus 4, sorry, 3 minus 7 is equal to 4, right? So we can say that if we do this split, our absolute difference will be 4. Right, now we can try the other split as well. So we have 4 as one of the possible splits, right? Now let's try the other split as well. We choose these and this one as a decreasing subarray. Okay, we need to split it into two subarrays, right? Left and right. So if we choose it like this, we have a sum of 7 here, right? And we'll have a sum of 3 here. Then again we get this difference as 4 itself, right? So the solution to this test case is 4 because minimum of both of them cases is 4, right? So answer will be 4 for this case. Okay, so let's try another example. Um, so let's try another example. Let's try the first example, right? 1 comma 3 comma 2. So in this again we need to split it into one increasing portion and one decreasing portion. So here one valid split would be this portion is increasing, right? This portion is increasing, and this is the decreasing portion, right? This is the decreasing subarray. Or we could have this be the increasing portion and this be the decreasing portion, right? So let's compare both the cases. In this case, it would be 5 minus 1, which is 4, right? In this case, the answer would be 4. And if we do the other split, if we do the split where this is the increasing portion and then this is the decreasing portion, here we'll get 4 minus 2, right? Here we'll get 4 minus 2. So the difference will be 2, right? And we need to choose minimum of these two cases. As you can see, minimum of these two cases will be 2, right? So that's why our answer will be 2 for this case. Okay. So let's have a look at the constraints. The 2, right? So let's have a look at the constraints. N goes up to 10 power 5. Each number also goes up to 10 power 5. So we know that we need some kind of big O of n type solution, right? We need some kind of big O of n kind of solution. Okay. So basically, we need to split this problem into two parts. Okay. One is to identify a valid split. Okay. One is to identify valid split. Okay. A valid split. And the second portion is basically to calculate the difference of the sum, right? The second portion is to calculate the left sum minus right sum, right? The absolute value of left sum minus right sum. Okay, so I'll call it LS and RS. So we need to find the absolute difference of left sum and right sum and take minimum of these, right? So now, how do we identify that a given split is valid? So for a given split, let's say we are going through the array. We are going through the array from left to right. Okay, we're going through the array. Let's say it's a pretty long array, and we're going through the array from left to right. So we need that both the left half will be we need that the left half will be increasing and the right half will be decreasing, right? So let's say we're at a given point in the array and we know that this much is increasing, right? We know that this much is increasing. As soon as we go to the next position over here, right, we can check if this is also in increasing order. Like let's say this was 1, 2, 4. Then if this is 5, then we can say that, okay, this is also in increasing order. So this is also a valid left half, right? We can say that this is also a valid left half, right? Otherwise, if let's say this was 3, for example, then this would not be valid because now 3 is less than 4, right? 3 is less than 4. So this is not a valid split. We cannot have a split after this point, okay? Because this is not increasing. So that's how, while iterating itself, we can check if the left half is valid. Okay, so we can check for left half. For the left half, um, we can check directly while iterating. Okay, we can check directly. Okay, but how do we keep track of the right half? So how do we keep track of the right half? Whether the right half is strictly decreasing or not? Because right now when we're iterating from left to right, we have no knowledge about what is there in this right half, right? And we want to find it in big O of n or n log n sum of whether that part is decreasing or not. So how do we do that? What one thing which we can do is we can do some pre-processing, right? Do pre-processing, pre-process the right half. Okay. So basically, for each position of I, we can pre-process whether it's a valid right half or not. Okay. For each value of I, we'll pre-process whether it's a valid right half or not. And the way we can do that is, um, if we go from right to left instead of left to right, yeah. If we go from right to left instead of left to right, then if something is strictly decreasing from left to right, then that thing must be strictly increasing from right to left, right? It should be something like this. This thing should be strictly increasing from right to left, correct? So for each position I, we'll have a bool value. Bool means true or false, right? We'll have a bool value which will say true or false to if till now it's a strictly decreasing sequence or not, right? Whether this value is less than this value, which is less than this value, so on, right? So if that is true, then this position will also hold true. Otherwise, if at any point it became false, then everything ahead of it will also become false. Okay. So let me just give you an example with some numbers. So let's say the value here was 1, then 3, then 7, then 12, then 15, then 13, 18, 20. Okay. So what would happen would be we would start over here and we would put the value true, right? At the last position. Then since 3 is greater than 1, this will also be true. 7 is greater than 3, this would also be true. 12 is greater than 7, this would be true. 15 is greater than 12, this would be true. But here, as you can see, 13 is smaller than 15, right? So everything from this position onwards would become false, right? And this is pre-processing if this given values are a valid split or not towards the right side. Okay, so whether they're a valid right split. It tells you if a given position I is a valid right split. Okay, valid right split. So now all we need to do is combine both of these, right? So we already had the left half. We could just iterate from left to right and check if the left half is valid or not. So now to check right half, we just need to iterate backwards. So we can pre-process this iteration backwards and we can store it. So now we can simply check during this I, we can check if I plus 1 is valid. Okay, during the iteration of I, we can check if I plus 1 valid is true, right? If I plus 1 valid is true and the current I is also valid, so that means both left half and right half are valid, then we can do the second part, which is calculate the difference between left sum and right sum, right? And how do we calculate difference between left sum and right sum? So we want sum left minus sum right. Okay. So how do we calculate this difference? Um, we can say that this difference is equal to the total sum, right? Total sum minus left sum minus left sum minus the left sum again, right? Minus the left sum again. Why? Because the right sum is simply total sum minus left sum, right? And their difference will be, so this is basically this is the right sum, and the total difference will be written like this, right? So this way we don't need to actually calculate the sums on the left and right. We can just find the total sum minus the left sum into 2, basically. So this will be total minus 2 times left sum. Right. So for each position such that the left half is valid as well as the right half is valid, we will update the smallest value of total minus 2 times left sum, right? So did everyone understand this? Yeah. Do you get this, guys? Let's have a look at the code so it would make it clear. The time complexity of this is obviously big O of n, right? The time complexity of this is obviously big O of n. Uh, yeah, so let's have a look at the code. So n is obviously the size of our vector, and then here we're checking if the current right sum is valid, right? So split of I means given the subarray from I to n minus 1, is it strictly decreasing? Is it strictly decreasing? Okay. So basically, I'm checking if this right half at a position I is valid. Okay. I'm checking if right half starting at position I is valid. It's the same, this bool array of true, 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 false, false, whether it's a valid right split or not, right? So this is my split array. Obviously, the last value will be true because only one element is a strictly decreasing array. Then from each I go from I equals n minus 2 to 0. If it is greater than the previous element, it's true. Otherwise, I can break and all the remaining values will be false, right? So this is how I'm computing whether the right half is a valid strictly decreasing array. Okay. Now the total sum will be the sum of all the elements. So this is just the total sum. I'm setting my answer equals infinity for now, since we want to minimize this. And this is going to be my left sum or prefix sum, right? P sum is equal to sum of my left elements. As you can see, I'm updating this, updating the prefix sum. Then what I'm saying is, if the given position has stopped being increasing, right? If the given position has stopped being increasing, if it starts decreasing, I can just break. So if left half has stopped being strictly increasing, then I can break, right? And also, if my right half is not valid, so if my split of I plus 1, split of I plus 1 means the right half is strictly decreasing. So if that's not valid, if right split not valid, continue, right? Otherwise, both are valid and the right is valid. In that case, my answer is simply the minimum of answer and left sum minus right sum, right? Left sum minus right sum, absolute value, right? And this is equal to total sum minus 2 times left sum, right? Total sum minus 2 times left sum. And I'm updating that. If in the end of this whole loop, the answer is still infinity, then there was no way to split it. So we can return minus 1. Otherwise, we return the answer itself, right? So I'll give you a minute to just go through the code, right? Here we are pre-processing the right half values. So pre-process the right half valid splits. Okay. And the left half valid splits we're checking while we're doing the code itself. Okay. Does this make sense, Arpit? And whoever had some doubt with B, please put on the chat if you have any further doubts with this. I'm sure there are other methods to solve this as well. Like, for example, you can show that there will only be 2 valid splits at most, and using that fact also you can solve it. But this is a very easy and standard way to do it by using like pre-processing the right half and then checking for the left half, right? Yeah, okay. All right, then let's move on to today contest level. A, B were simple. C and D were on the harder side. I feel D especially was harder. I could not solve it during the contest. So I could say D was much harder than usual. But it was a DP topic, I think. So Life in Engineering asks, do I find the overall sum and pre-compute increasing and decreasing? I'm not quite getting what are you asking? Yes, yes, you're pretty much correct. So you're pre-computing whether the current point is valid from the left half and the right half. So yeah, you're doing that. and then you can check the overall sum to find the left sum and the right sum, and then you can take the absolute difference and you can update it. So I guess you're kind of correct what you're saying. Although here I'm only pre-computing the right one. I'm not pre-computing the left one because during iteration itself I can do that part. Okay, I'm only pre-computing the right half is valid or not. I'm not pre-computing if the left half is valid or not. Okay, so let's move on to the third question now. Problem C. Okay, problem C. Okay, number of zigzag arrays. You're given three integers n, l, and r. A zigzag array is defined as follows. Each element lies in the range L to R. No two adjacent elements are equal. No three consecutive elements form a strictly increasing or strictly decreasing sequence. Return the total number of valid zigzag arrays. Since the answer may be large, return it mod 10 to the power 9 plus 7. And they've defined what strictly increasing and decreasing means. N here goes up to only 2000. L and R also go up to 2000, right? So we can write it as N goes up to 2000, right? So you can guess that the expected time complexity would be big O of N squared, or maybe big O of N times, it could be something like big O of N times R minus L or something like that, right? You could guess the time complexity as something like this. So basically N squared solutions will pass, and we need to find the total number of zigzag arrays. Okay, so let's try to understand what makes an array a zigzag array. So we know that each element lies between L and R, and basically the main point is that no three are strictly increasing or strictly decreasing, right? So in essence, what that means is our array is going to look something like this, right? If it's either a zigzag like this, like higher value, lower value, higher value, lower value, higher value, lower value, something like this, right? So this is a valid zigzag array, like you're going like this, or you start with a smaller value, you go higher, lower, higher, lower, higher, lower, higher, lower. So this kind of zigzag pattern gets formed, right, in your elements of the array. I hope you're getting me. So for example, we start with a value like 4. We can go to a smaller value like maybe 2, then go to a higher value like 7, go to a smaller value like 5, go to a higher value like 9, go to a smaller value like 1, so on. This is a zigzag array. Another possible zigzag array is like you start with some value like 5. Now you must go to some higher value. So you go to 10, then 1, 7, 6, 15, 3, so on, right? So in this, it's larger, smaller, larger, smaller, larger, smaller. In this, it's smaller, larger, smaller, larger, smaller, larger, smaller, larger, right? So these are the two kinds of zigzag arrays which are being formed. How to frame a code nicely, even if you write a good test case in time complexity code, your code is bulky. Well, that comes from practice, but also if you sit down before coding and you spend 5-10 minutes thinking of how to simplify your code, it does help. So especially if you're starting out, you should spend some time thinking out how to, implement in a more efficient way, even if your time complexity is correct. Like just on pen and paper, like do the pseudocode and simplify it. Then it won't be that bulky. Um, Ishan says, what if you make DP with total count, last taken, strictly increasing? Okay, I'm not quite sure what exactly you're saying. Can you clarify this? Anyways, yeah, the solution to this is DP, but we'll soon get into that. Okay. So now we need to maintain the counts, right? So how do we do that? Um, you get stuck on question 3 always. Well, then that means that you need to learn some standard topics, right? So usually question 3 will use some standard topic like binary search, two pointers, combinatorics or DP. So you can try the level 3 or level 4 courses on TLE, or otherwise you can just see these topics, right? See these standard topics. Two pointers is common as a third question. Combinatorics is common as a third question. DP is common as a third question. Some basic graphs are common as a third question. So you should practice these standard topics and practice that level of questions. That's pretty much the only way. Anyways, back to the question, guys. Um, yeah. So here we're gonna do the following, right? We're gonna think about I need to count the number of um arrays, right? Count valid zigzag arrays, right? Count valid zigzag arrays, correct? So often in counting problems we use DP, right? But that's not the only intuition to use DP. Um, how do we understand that we need to use DP? Because we have to count how many arrays of a given length can be formed following some pattern, right? And these kinds of questions are usually DP. And the way we're going to do it is we're going to be like, okay, um, if I can have, let's say, have n for a length n. So if for a length n, for some length n, for some length n, length n, I have some count. Okay, I have some count. I have some count. Then what will be the count of valid zigzag arrays for length n plus 1? Okay, so what will be the count? What will be the count? What will be the count for n plus 1? Be the count for n plus 1. Okay, for n plus 1. And that's kind of what we need to figure out, right? That's kind of what we need to figure out. Um, what will be the count for length n plus 1? And so what we can see is, right, only the last character is changing. Only the last character. Like for example, we already have a zigzag array of some length. So let's say 7, 5, 2, 1. No, wait. 7, 5, 8, 2, 3, 1. Okay, so we have a zigzag array like this, and it has some length. It has some length 6, right? So this one has length 6, and L and R does not really matter right now. So we can say that okay, L is obviously the minimum value is 1, and let's say the maximum value of R is 10, right? And we have already made a zigzag array. So as you can see, this array is zigzag already of length 6, right? So now the only thing which matters is what is the possible values of next character which goes here, right? What are the possible values of the next character which goes here, which is why we get the idea that we can do DP, because given some n values which are already fixed um, for the previous zigzag array, we can find for n plus 1 size zigzag array by thinking about what are the next possible values which can go after this one, right? So we can see that this zigzag is like a large, small, large, small, large, small type of zigzag. So then the next value must be some value which is larger than 1, right? The next value can be any value which is larger than 1. And how many different values are there? We can see that since L is equal to 1, R is equal to 10. So there are 9 possible values. So it can be either 2, 3, 4, all the way up to 10, right? All these 9 possible values are there. for the last element, right? So that's why we say that after this, we get 9 different possible values. So we get like this intuition that we should use DP. Okay, so this is our intuition, is that basically for a given um, n, if we have the counts of the different arrays, zigzag arrays, then we can transition to having the count of different arrays for n plus 1. Okay, so this is just me giving intuition. We'll do it formally now. So this is the intuition for why we need to use DP, why DP transitions might help us solve this problem. Okay, so this is our intuition. This is our intuition. Okay, so yeah, so how do we get into the DP transition? Now that we have an idea, okay, why we are thinking about DP, let's try to figure out what is important at a given stage. Okay, so what is um, important at a given stage? We need to understand what is our DP state. Okay, so if we are going to do a DP, we need to know what is our DP state. Okay, what is our DP state? What is our DP state? And that's what we need to figure out right now, right? Okay, so basically the intuition, Madhav, is that um, if you have a given like count for some n, right? Then the next state only depends on what is the next number being added, what is the n plus 1th number being added, and that's the only thing the next state depends on. That's why we are getting the intuition to do the DP, right? That's why we're getting the intuition to do the DP. We're currently on the third one. We're on the third one, Pradeep. The intuition is basically, look, actually, to be honest, if you solve enough of these problems, you will know that it's DP instantly. So that's why one way you can say is just solve more problems and you'll get the intuition. But I am trying to explain, but I'm trying to explain the intuition. I'm trying to explain the intuition by keeping in mind that given the previous n values, the next value gets already decided, right? The next value has to be great. Like if this is a zigzag array of this type, then the next value has to be larger. Or if it's the zigzag array of the opposite type, then the next value has to be smaller. And then we have some particular values for that. So that's basically the intuition that to, to maintain the count, we need to do transitions which only depend on the next value being added. So that's the intuition. Yeah, so if you do it this way, it might take n cubed naively. Sorry about the gap. Um, yeah, as in we're choosing which values can be appended. So, okay, so I'll get into the DP state that will make it clear. Yeah, so let me get in the DP state and I'll explain the whole DP. Maybe then after that it'll become easier to understand. So, what is important in our DP state, right? So it should be what is the last character, right? What is the last number which appeared? Last number, last number which appeared, okay, which appeared. This is important, right? And also what is important, whether it's an up-down zigzag or a down-up type of zigzag, right? So whether it's an up-down type of zigzag or a down-up type of zigzag. So for example, what is also important is what type of zigzag is it? What type of zigzag, right? So based on that, we can decide on what is the next possible numbers to be appended. So let me just give an example. If I have, let's say if I have, let's just make our L between 1 and R between, let's say, 5. Okay, so our ln R is 5, just to keep things simple. Okay, so at a given position, so if at a given position I have dp of I, and let's say the possible ending values, right? All the possible values it can end at. So that will be my second dimension of my dp. So I have dp of I1, dp of I2, dp of I3, all the way till dp of I5, right? So these are the possible ending values, right? So let me just write those down. Okay. And then I also want to know whether the last position was going down or was the last position going up. Okay. So if the last position in my array was going down, then the next value must go up, right? So I need to keep track of that. So for that, I'll have a final state, which will be like 0 or 1. Okay. So the final state will be 0 or 1. 0 means the last position was going down, and 1 means the last position was going up. Or in other words, 0 means the last position was decreasing, 1 means the last position was increasing. Okay. So for example, um, let's say I have 1, 2, and 1. Okay. So we can say that for this three, um, for this length 3 array, length 3 zigzag array, we can say that the last value is 1, right? The last value is 1, and it is decreasing, right? So this will go in dp of 3, 1, 0, right? Because it has three numbers. It has three numbers. The last number is 1, and that it's decreasing, right? So this is going to be a dp state. And for example, if I had, instead of this, let's say I had like 4, 2, and 5, right? So I can say that my last position is 5, and that's it's increasing at this position, right? So then it will go to deep I will be equal to 3 because it has three values, and then the last value is 5, so the next second value will be 5 for this state, and this will be 1 because the last state was increasing, right? So that's how I'm classifying my dp states. Okay, so yeah, it's a normal dp state type of question. um and the way we'll maintain count is we'll make a vector of, or we'll make an array or vector, whatever you like. It will be um so n values, right? N values. The second state can take all values between L and R. So that's why it will have L, R minus L plus 1 possible values for the second state, right? R minus L plus 1 values for the second state. And the final state has two values, whether it's increasing or decreasing at the given point. Okay. So this is going to be a DP vector. This is going to be a DP vector, right? These are the possible states we are having. And this is going to store the count of how many have length n. So this is going to store the count of how many have a given length, right? This is going to be the length, and this is going to be the last value. How we're storing our DP. Then we can do transitions from a given length to the next given length. So just take a pause. See, if we have computed for everything up to I, then we can compute the states for I plus 1 as well. So can you pause and think about it? Like, is this understandable what our state is? This is our state. This is going to be the length. This is going to be what the last character was, and whether the last character was increasing or decreasing. So what type of zigzag was it? Was it this kind of zig? Was it this type of zig, basically? Why can't we take two increasing or decreasing consecutively? If we have two increasing consecutively, what if we have? Yeah, okay. Let me just answer for Ishan. So basically, we're not taking two increasing consecutively because that means like we need a zigzag pattern, right? So if this was also increasing and this was also increasing, then that means that we got three values which are increasing in continuity, right? We got three values which are increasing in continuity, right? That's why we can't have two increasing continuously. We need to have like a zigzag, right? As you can see, this one is decreasing, this one is increasing, and this one is decreasing. It's given from the problem constraints itself that there should be no three consecutive elements which form a strictly increasing or strictly decreasing sequence. So we can't have an element increase from the previous element and then increase again. Okay, so yeah, I hope you understand that issue. Anyways, yeah, we need to get into how to do the DP transitions, right? So let's write down the transitions. So let's say given an I, what we'll just write down transition. We need to think about the transition. Okay, so given an I, and let's say it ends at some particular number, right? So let's say it ends at some particular number. Let's call it X, right? Um, and let's say it has the current pattern over here is increasing, right? Let's say the current pattern is increasing, so we'll call that one, right? So that means that it should have come from some number X minus one. So it should have come from some dp I minus one, right? It should have come from dp I minus one, such that if the current thing is increasing, then the previous one should have been smaller, and it should have been um, decreasing, right? So that's what it should have. So we can say that for any y which is less than x, right? So basically, if at the current position it has an increasing pattern, right? If at the current position it has increasing pattern, obviously it's larger than the previous element, and then the previous element should have had a decreasing pattern, right? So dp of I x comma 1 will be the sum of all y less than x for this. Okay, so here I wrote y less than x over here itself, so I can just erase that. I'll just write y. Okay, so I can write y is 0. Right, I find it really difficult to think iterative. Recursive one feels intuitive. To be honest, that comes mostly with practice. uh I suggest watching Ericto's videos on DP. Like, he has 2-3 videos only, they're like 10 minutes each. He talks about the iterative approach mostly. Please go through that. And um yeah, so it comes with practice. That's the only advice I can tell. I got this question multiple times, right? How to think of the iterative way instead of the recursive way. And it's mostly like you think about the states, you think about how to get the current state from a previous state. Like here, the current state is I state. How do I get it from the state of I minus 1? Right? So this is my I state and this is my I minus 1 state. And think about how to get this state. And that's basically the logic, right? And if my current value, let's say, we can take a specific example, okay? So I am trying to find for length, let's say n equals 5. For length, let's say n equals 5. My last number, last digit, my last digit is, let's say, 4. Okay, my last digit is 4. My last digit is 4. Then, and also current pattern is increasing, right? The pattern is increasing. So what do I want previous to me? What do I want previous to me? I want the sum of all the counts of n equals 4, right? N equals 4. Last digit should be less than 4, right? Last digit should be less than 4. So last digit should be less than my previous last digit, right? So here, if my last digit was 4 and my pattern is increasing, that means the previous value was less than 4, right? And here the pattern should be decreasing because it should be a zigzag pattern. So the pattern will be opposite, right? Pattern should be decreasing, right? So that's what I'm looking for. So in other words, you can say that there are 5 elements here: 1, 2, 3, 4, 5, right? Last digit is 4, and this is some value smaller than 4. This value is smaller than 4. then that means it can come from any 4-digit case. It can come from any 4-digit case where the last digit can be 1, the last digit can be 2, the last digit can be 3, right? All the values which are less than 4, basically, right? And then this should be decreasing, like this is increasing. So then this should be a decreasing one, correct? So that's why we are getting our DP transition. I did this with prefix sum optimization and still got TLE. That I'm not sure why you did that. Maybe did you declare your DP array globally? If you did not declare your DP array globally, then you might get TLE in that. That's the only thing I can think of, because my solution is also the exact same. The same DP with prefix sum optimization. For next position, taking last number and multiply how many distinct. Yeah, it's pretty much this, yeah. So Arpan, the way Leetcode, this is a Leetcode specific thing. So the way Leetcode runs its problems is basically for each test case, it makes a new class solution, right? So if you have a DP array, which is getting again made n square times, then for each test case, it's going to make this. So that's a Leetcode specific problem, I think. It's not your fault. So if you declare it globally, then each time when Leetcode makes class solution, it won't redeclare the whole DP array, right? So that's why you need to make sure that your DP array is global in Leetcode. Okay, guys, so what have we looked at? We have looked at what the state looks like, right? So this is the first thing, what the state looks like, right? So this is our state. Second thing we have looked at is the transition, right? And so this is only transition for the one case. What about the transition for zero case? Well, transition for zero case, DP of I x 0, right? If it's 0, it means it's decreasing, right? So the previous element must be larger. So this will be the sum of all. Here it's y less than x. Here it will be y greater than x, right? Sum of all y greater than x. DP of I minus 1, y 1. Okay, right. So these are our two DP transitions. Okay, so this is the transition for the last state as 0, and this is the transition for the last state as 1. So if you don't get this, just go through the code once. It makes it much more clear. You can even rewatch the video after going through the code. So that would help a lot, I think. So we'll get to the code soon enough. Okay. So yeah, sometimes while learning these kinds of like this is almost 3-dimensional DP, right? So it takes some time to understand it fully. Okay. So if we want to code this up directly, this will fail because this will be big O of n cubed. Okay, this solution is big O of n cubed because first there are total n square states, right? There are total n square states. Total states is equal to n times r minus l plus 1, right? Times r minus l plus 1, l plus 1 times 2, right? So r minus l is at most 2000, n is also at most 2000. So this the number of states will be n square states, right? N square states. And because this transition has a sum over here, because as you can see, this transition has a sum. So for each time you're doing a transition, you can be summing up to n values, right? You're summing up to n values, right? Summing n values each time you're doing the transition. So that's why if you do the transition naively, the total complexity will be big of number of states times times of transition. So n square times n. So your time complexity will become big of n cubed. Okay. So that will be the total time. But we have to do it in big of n square or less, right? Like we discussed in the very start, the expected time complexity is big of n squared or less, right? We need something which is big of n squared or less. So this is the expected TC, right? So how do we do that? And the way to do that is by identifying that this sum which we are taking, right? This sum which we are taking is for all the y which is greater than x, right? So for all the for a given x, we need the sum of dp of all the y greater than the x, right? So the way we can do it is by maintaining like a prefix sum or suffix sum, right? The way we can optimize this, optimize by maintaining a prefix or suffix sum, right? Prefix, suffix sum. In fact, we don't need to create the array. We just need one variable. Um, we need one variable itself while updating, which can store the current prefix sum or current suffix sum, right? So instead of taking big O of n to do this sum, we can just find this sum in big O of 1. I'll show you the code, then it'll make more sense. So by using prefix sums or suffix sum kind of optimization, we can reduce the time complexity to big O of n squared. Okay. So while doing the DP transitions, when we use prefix sum, we can reduce this to big O of n squared. As the common trick, this is a common trick to use this, right? It's a common trick in DP. If you solve enough DP problems, you'll definitely see this at least a few times, right? Um, Someone in the chat had also found out how to do this, but I think they did not make a global array. That's why they were getting. You should declare it outside the class, Arpan. Okay, so let's have a look at the code now. Okay. So yeah, first thing in Leetcode, you should always declare your DP array outside your class. Okay. This is a note for everyone. Otherwise, you might get issues with time limit exceeded because each time the class is being created, this whole DP array will be created, and that will cause time limit exceeded because of the way how Leetcode process your test cases. Okay. For each test case, Leetcode creates a new class. So that would mean that, you know, you would get time limit exceeded on this. Okay, so we make our DP array. As you can see, the DP array is 2000 by 2000 by 2, right? And the reason for that is simple because this was our DP array, right? N r minus l plus 1, 2. So this is at most 2000. This is also at most 2000. That's why we're making an array of size 2000 by 2000 by 2. Okay. Okay, and then we're also taking our mod value. So all our calculations for count should be taken with mod, right? So each transition when it is done needs percentage mod. So you need to keep that in mind. If you forget that, obviously you'll get wrong answer, or you'll get overflow error. Okay. So yeah, here I take r minus l plus 1 as m just for convenience. Okay. And my dp of 0, yeah, so we need to discuss the base case as well, right? Base case, base case, and base case will be simply dp of 0 for a array of length 1 or length 0. Like I'm doing it 0 index, so dp of 0 means length 1 array, right? Length 1 array. And what are the possible values for length 1 array? Well, it can be 1, 2, all the way till r, right? So from L all the way to R, we can have a length 1 array. There's no restriction, right? So L, L plus 1, L plus 2, all the way till R, we have this. Each of them has a count of exactly 1, right? Each array has a count of exactly 1. So that's why the base case is simply dp of 0, y or x, dp of 0, x, 0 is equal to 1, right? And dp of 0 x 1 is also equal to 1, right? Because increasing or decreasing does not make sense in one element. It can either be a zig type of ending or it can be a zag type of ending, doesn't matter, right? This is our base case for all x, for all x, for all x, for all x, right? So in our DP, we need three things. We need the base case, we need the transition, and we need the final case, right? And what is our final case? Final case is simply total number of ways. So final case will be sum of all dp of n minus 1 x and 0 dash 0 or 1, right? So this will be our final case or final answer, right? So this is our final answer. This is our base case, and this is our transition. We're optimizing this transition using prefix sums, and that's the code we're going to discuss. Okay. So here I just implement the base case, right? Also the case for DP of 1, I wrote it down manually, although it's not needed to write it down manually, right? I don't know why I wrote it down manually because it's a bit slow. Yeah, so we don't need to have a separate case for DP of 1. We just need the DP of 0 base case. Okay, so now for I equals 1 to n, um, here we have a prefix sum value, right? So basically, each DP of ij is being set to the prefix sum. The prefix sum is being updated with DP of I minus 1 j1, right? So for 0, we are having the opposite state of 1. So basically, every DP of ij is being the sum of all the smaller j's, right? So for DP of ij 0, sum of DP of I minus 1 j dash 1 for all j dash less than j. Okay, so I hope you understand what this means. It's the sum of all dp of I minus 1 j dash 1 for all the j dash which are less than j. Okay, so for all the values which are smaller than j, we are summing up the dp of I minus 1 values, right? So that's all this line is doing. So this is calculating dp of I j 0, and now we need to calculate dp of I j 1. So 1 means it is increasing, right? So dp of I j 1, and that will simply be the sum of I minus 1 j dash 0, right? For all j dash greater than j, right? For all j dash greater than j. And that's why we're going from larger to smaller here. We're going from j equals m minus 1, j less than equal to 0. And we're computing suffix sum, right? We need suffix sum. We need the sum of all j dash greater than j. So we're computing the suffix sum. We set this dp to the suffix sum. Then we update the suffix sum with dp of I minus 1 j 0, right? And make sure to take the mod. Make sure to take the mod. Otherwise, it will overflow. Now for the final answer. Final answer. So the code itself is pretty short. It's just a standard DP, right? Base case. So now for the final answer, it's simply the sum of um, all the values of DP of n minus 1, j0, n minus 1, j1, right? So the last digit can be anything, and it can be either increasing or decreasing. So as long as they're n digits, that's what we need. And then we sum that up and we print our final answer. So that's the code for this question. I hope it's understandable. It's a bit hard to explain DP because it's a very standard DP. If you have done it before, you will definitely do it. If you have not done it before, it will be a bit hard to understand. But do go through the code. I heard yesterday's lead code was pretty easy, so don't worry about it. Yeah, we can just use the current and previous state. So behind the screens, you're correct. If we just keep the current and previous state, we will save on memory complexity, right? So my current memory complexity is big O of n square, right? So my time complexity is big O of n square, and my memory complexity is also big O of n square, right? Time complexity is big O of n square, and my memory complexity is big O of n square. But if you only store the current and previous state, we can reduce our memory complexity to big O of n. Okay. If you do what behind the scenes said, then yeah, you can do it in big O of n memory only, right? So if you store only current and previous of your DP, store only, instead of storing the whole DP table, you store only the current, which is I, and your previous, which is I minus 1. Can I explain the prefix and suffix logic? Okay. So basically, if you observe, dp of ij0 has to be the sum of dp of I minus 1 j dash 1 for all j dash less than j, right? So we can write it as dp of I j 0 is equal to gp of I minus 1, 0, 1, right? Plus dp of I minus 1, 1, 1, plus dp of I minus 1, 2, 1, plus dp of I minus 1.
उसको क्यों छू रहे हो? उसका कोई गलती नहीं है, समझे? नहीं नहीं, ये क्या बकवास तुम्हारी माँ लगाई हुई है सुबह से?
Yeah, so where was I? Yeah, so we're storing on. Yeah, so where was I? Yeah, we're at yeah, so if you do it manually and you write it out, you see that we're having this sum all the way up to j minus 1, right? We're having this sum all the way up to j minus 1, right? So we need this sum, right? And basically we're just doing a prefix sum. So since we're going from j equals 0 to j equals m, for all the j which is smaller than this, we can just sum them up, right? So that's why we can just use the prefix sum instead of doing this in big O of n cubed, right? If we want to calculate the sum each time, it will become big O of n cubed. But by showing the prefix sum, we're doing this in big O of n squared. So that's about it, right? Yeah, I think that's the only issue, Arpan. Yeah, everything is fine, Sam. No issues. Okay, then I think that's about it for this session, right? If you didn't quite get this question, you can go through it once again. You can go through the code because if it's your first time seeing it, yeah, I can understand why this would be a bit hard, but it is a kind of standard DP question. As for problem D, I couldn't quite get it during the contest, so yeah, you can go check it out. Thank you, Sam. All right then, guys. Thanks for watching. Do upsolve the questions, right? So if just watching the PCD won't help you that much, you should upsolve it afterwards. Whichever is the next question you didn't get, do upsolve it. Thank you, and see you in the next session. Bye bye.